Anytime you're comparing two population parameters, such as two mean values, here we're looking at the mean score for students using the courseware versus the mean score for students who don't use the courseware, then you always want to use a two-sample t-test. Okay, and we're using a t-test because we don't know the population standard deviation for either populations. Now notice that the sample mean, so from the sample of student scores, the average score for the group using the courseware was an 82.8 compared to the average score for the students who didn't use the courseware, which is a 75.7. So the sample data does appear to show that students using the courseware on average have a higher score. But we want to make sure that that difference is real. Okay, what I mean by that is we got to make sure that it's true for the entire population, not just from this sample. So to do this, let's go ahead and do a hypothesis test by writing out the null and the alternative hypothesis. So the claim that we're trying to test is we're trying to test the claim that the courseware will improve students' scores. That means that we are assuming that mu sub 2 is going to be greater than mu sub 1. So I'm going to keep track that that's the original claim, so I know how to state my conclusion at the end. And then the null hypothesis, don't forget, it always contains equality, so it always has the equal sign. We always assume that the two mean values are the same, and then we go from there. So again, I want to make sure that this difference between x bar sub 1 and x bar sub 2 is a real difference. Is 82.8 minus 75.7, which is a difference of 7.11. So I want to know if this difference is a real difference. Clearly, it's not 0. And my gut feeling, it feels like it's kind of far from 0, but I want to double check to make sure that it's statistically significant because you can't just trust your gut feeling. So what we're going to do here is calculate that test statistic. You can use formulas for this, but if you're using that two-sample t-test on your calculator will give you that t-score, which is 2.56. So using this test statistic, we can calculate its corresponding p-value. And again, if you're using the two-sample t-test function on your calculator will give you that p-value as 0.0082. So what I'm going to do now is use the p-value method to compare the p-value to my significance level to make a decision about the null hypothesis. So here, my p-value is 0.0082 is less than our significance level of 0.05. Therefore, I'm going to reject the null hypothesis. Okay, now let's write this out as a conclusion about the original claim. So then because we reject the null hypothesis, so we just reject this, what we're saying is we do not think that the mean values are the same for the two populations. The data actually supports the original claim, which is the alternative statement. So let's go ahead and write out the conclusion. We can say there is sufficient evidence to support the claim. And then you just write out the original claim that the courseware does improve students' test scores.